That's us, right? Okay. All right, good afternoon. So I'm David Woolf from UNH-IOL, and I'm actually going to talk a little bit about... Oh, there we go. Sorry about that. Talk a little bit about some Plugfests that we've done in the past, similar to some of the things that Ray was just talking about with OP and FE, but a little more focused on the hardware side. And then more recently, a project that we've been doing with Facebook that's actually kind of taken that Plugfest work and some of the effort and processes and test procedures that we kind of built there and taken them to the next level and refined them a little bit. So, all right. So first, just one slide about who we are. We're an interoperability lab housed at the University of New Hampshire. We're actually celebrating our 30th anniversary this year, so we've been at this for quite some time, and 100% funded by commercial industry. So the services and the programs that we offer, that's what allows us to exist. We're not on like a grant or anything. We've been working with Open Compute project since 2015. And it was in 2015 that we started our Open Networking Integrators list. And the purpose of that list was to showcase what combinations of switch, open networking switch, network operating system, and optic, and I say optic, but really any kind of connectivity, whether it be an optical module, an AOC, or even a passive DAC cable, show that those things work together. Because for disaggregated networking, for open networking to really be a reality, this very fundamental level needs to be working, right? We need to have some confidence that we actually plug in different types of cables or optical modules that they're going to work. And we're all familiar with the idea that for a long time, a lot of integration, a lot of switch companies, they'll do whitelisting and blacklisting of certain types of connectivity. And they'll have their reasons for doing that. And of course, end users and customers have their reasons for wanting those things to be turned off and actually proving that things are interoperable, whether they be proving that these different types of connectivity are interoperable. And that's really what this project was all about, was proving to do that. And so we had a series of Plugfests. We've had 5 so far now at UNH-IOL. And we've used that time, as well as the time in between, to do a bunch of interoperability testing on these different combinations. And so we've got over 140 combinations posted on that list now. Now, I'd like to, as much as I love Plugfest, and everybody loves doing a Plugfest, it's important to understand that there's limitations for it. It's a time-limited thing. Usually takes about a week. And there's good things about that, and there's bad things about that. So just a little kind of pros and cons there. For one thing, the pros, it's great to have everybody in one room. Ray talked about that in his presentation, that, hey, it's nice that people are actually able to work together and kind of know what each other's doing and have the opportunity to spend time together and solve problems together. There's buzz around a Plugfest. It's an event that you can point to, kind of drum up interest in, and publicize the results afterwards. So that's a good thing too. It tends to be, it's a sprint. When we're in a Plugfest, everybody's trying to solve a problem, and we end up taking kind of big steps forward in terms of proving things that work, in terms of refining our test process. We do a lot of that in a very short period of time. Depending on our attendance, we can have good mix of hardware and software vendors, maybe people that we didn't expect to be trying to get them to work together. So that's another interesting point about a Plugfest. And of course, the opportunity to refine the Plugfest, or refine the test process. But again, you can only do so much in a period of 4 to 5 days. So a lot of times when, speaking for UNH-IOL, when we do a Plugfest, usually that's kind of a kickoff for a bigger effort. And so last year we did this Plugfest focused on CWDM4 optics with Facebook, and that ended up being a kickoff for a longer interoperability project that we were able to do, focused on the Wedge100 project. So that's kind of what I'm gonna talk about with that. And I call it kind of the Interop challenge. And our challenge, in a sense, was instead of trying to mix and match all these different things at a Plugfest and try out all this different hardware, all these different connectivity methods, all this different software, we're going to focus on one piece of hardware, Wedge100, a relatively limited set of software. We focused on Cumulus, a couple different versions of Cumulus that we ended up using, but then we're going to try and test that limited setup against as many different connectivity options and optical modules and cables as we possibly could. So I kind of think of it as like casting this huge net and trying to capture as many different combinations as possible. So it was a really neat kind of opportunity to do that. And so again, I contrast that with casting a net over all these different connectivity options. It's like casting a net into the ocean trying to catch fish. And then kind of at the Plugfest, in a relatively short period of time, trying out some interop configurations that have already been identified before the event. We're doing it with only a relatively small number of combinations that you can actually test during that time. It's relatively brief in that we only do it in a week. So just a little bit of contrasting again the difference between what we've done at those Plugfests, which are great and they have a purpose, versus what this was, definitely a longer term thing and targeting more combinations. So one of the things that we came to during our Plugfest and that we actually implemented during this project focused on the Wedge100 was some test optimization. So I presented before here at OCP about the testing that we've done as part of this Open Networking Integrators list. And one of the things that we did was actually kind of a full electrical validation of our cables, a full electrical validation of the modules and the electrical interface on the modules. And that takes some pretty expensive equipment. It's actually fairly labor intensive. And so in here we're thinking, well, we're really more interested about the interoperability side of things. And so is this an opportunity where we can optimize and kind of pull out this kind of labor intensive, relatively expensive testing that we can do? There's a time and place for that. But for this, where we're trying to test as many combinations as possible, really what we want to know is, are these optics DOA or not, really? So we just switched to doing a very simple BER test with a Viavi T-Bird. And anytime that you're simplifying the test process or optimizing the test process, one of the things that you're worried about is, well, now are there failures or things that are broken that are going to slip through? And so if I simplify my test process, if I optimize, and now all of a sudden everything's passing and everything works, that's a red flag, right? Because I was catching things before with my more complicated test process. I decided that was too much work and I've optimized it a little bit, and now I'm not catching anything. We should be scared about that. And so we were curious to see what was going to happen when we switched to doing this BER test. And the good news, in a sense, is that we actually still found things that were failing. And so that kind of told us, okay, we did this optimization, we're still finding failures. This was an okay optimization to do. And so we proceeded with that. A number of Interop partners that we've been able to work with on this project so far. These are ones that you can now find on the Open Networking Integrators list being paired with the Wedge100 product. A number of AOCs, DACs, and optical modules, CWDM4 as well. Some folks are interested in knowing that. So what did we catch out of all this? We threw the net out there, and what did we catch? And there's some fish that you want to keep and some fish that, well, maybe you want to throw back. So what did we get out of this? Well, one thing that should be clear to people is that OCP is not on its own, for all the great things that come from having open hardware and having disaggregated hardware, this is not a fully integrated solution. And so as folks are deploying that, they need to be aware of that these solutions, work needs to be done ahead of time in order to ensure that they're interoperable. And that's kind of part of what our project was all about, is proving ahead of time what modules are going to be interoperable with a very focused set of hardware and software. Some of the things that we saw, simple things like incorrect EEPROM programming. So something was programmed as a 40 gig module when it was actually supposed to be a 100 gig module. Simple things like that. We saw cases where people failed the BER test. And so, well, we're not going to then take the next step and actually put them into our test network. We saw cases where an EEPROM could be read properly on an EEPROM reader, read properly by the switch, and it wouldn't actually get turned on by the switch. The light wouldn't actually turn on. And so these are kind of relatively simple interoperability problems in a sense. They can be very obvious. But this is exactly the kind of thing that we were trying to catch in doing this project. And so those were things that were failure cases that we were able to find. And so again, as you optimize a test, as you perform a test, if everything is working beautifully all the time, that's a little bit of a red flag, right? That maybe you're not as rigorous as you could be. So in a sense, we were kind of happy that we found these things and knew that we were actually catching problems by doing this. But at the same time, actually proving that on the whole, we were seeing pretty good interoperability. So overall, we were able to test up to this point 45 different SKUs from 10 different module and cable companies tested against that single platform. And this project is ongoing. Of course, if there's other module companies, AOC companies, DAC companies that are out there that would like to participate in it, the door is still open. So we still invite people to come and participate in that and see that number climb even higher. So these are kind of the good things that came from that. Yeah, there was some interoperability issues that we find with the optics, but then we also proved that a whole bunch were actually working really well. So we're really happy about that. So one of the things that we want to kind of pay attention to when we're deploying these things is we don't want to assume anything about whether things are going to work together. So previous version of software, hey, we've upgraded it. It's not that different from the old one. It needs to be tested. There's something different there that could come back and bite you. Oh, this one has the same silicon as the other one, so we should be good. Again, those minor differences, minor updates and revisions and so forth can introduce interoperability problems. Even things where like, well, this is the same model number that we saw on a previous one. And now maybe a different batch, but the same model number. Even there, we've seen cases where things behave a little bit differently. So again, some of the successes that came from this, we were really able to distinguish this combination, this particular combination that we were focused on, the Wedge100 with the Cumulus NOS, really able to distinguish it by giving it a really wide demonstration of interoperability. So it kind of highlights that here's a solution that has a lot of different interoperable partners with it. Like I said, we're still inviting the connectivity community to participate. Also, we demonstrated wide interop at 100 gig. That was another success. The other interesting thing about this is other end users are following suit. So I see this as a really big opportunity for OCP. Facebook kind of stepped up and said, hey, we'd like to demonstrate that there's really good interoperability for this particular product at 100 gig. And I think this project has shown that. Other end users are kind of taking notice of this and saying, this is something that we would really need too. We'd like to know whether or not the stuff that we're buying and the stuff that we're deploying has wide interoperability. And so there's other folks that are pursuing similar types of projects with us. I view that as a really big opportunity for OCP. So in terms of promoting the idea of open hardware, of promoting the brand of OCP, there's a lot that can be gained here by continuing to do this kind of interoperability testing and make it so that OCP itself could be known as an interoperable technology and interoperable community. So a lot of successes from that. So questions from that? Yes, please.
In one of the catches, there was ONI support. I'm just curious to know if ONI support had anything in particular as a challenge towards interop.
Yeah. So keep in mind what ONI is supposed to do. ONI is kind of, it's the open network install environment, streamlines the ability to install NOS on a particular switch. And so one of the things that we found here was that support in the switch can be variable depending on different BIOS versions, different silicon in a switch. You might find, even again, if it's kind of the same model number, those might not have full ONI support yet. So we kind of had to work on getting the right combination of NOS, BIOS support, and hardware to get a solid ONI support. That's what I was talking about there. Yeah.
Just in relation to that, there's also this EFI and a legacy version of ONI, right? So did you have to, did you, in your experience, run into any issues with that?
That wasn't an issue for us, yeah. I've seen that thing floating around on the ONI mailing list, but that wasn't a particular issue for us. Yeah, at least in this case. I don't know if that'll come up in other switches that we're doing ONI testing for.
In your testing of optical modules, Did you look at the accuracy of the DOM values that are returned to give the power levels that are received from the far end?
So what we did there was we would compare what we were getting from just a I2C reader versus what was being reported by the switch. And so we would compare and if those things matched. Now, what those values are and then what the OS decides to do with them, we didn't look into that. Yeah, so it was just kind of a, do these match? They better, right? Sometimes they didn't. But no, we didn't go into quite that level of detail. All right, great. Thank you very much.